I hand over the stage back to him. Please enjoy the tutorial for the day. Thank you.
Thank you. Thank you, Sudarshan sir. Thank you for the nice introduction. Good morning, all. Um, um, as of from the OT world, we know how to use the PKI, how the deployment of PKI and into the field, what challenges we face in the OT the domains. Can you just speak that? Yeah. Hello. Yeah. I mean, okay. Sorry. How the OT world sees this PKI infrastructure? Hello. Yeah. So the adaptation challenges with respect to OT systems and the international standards, what they talk about the yeah. What the international standards which talks about on OT systems, the compliance perspective, what are the challenges and how we adopt the solutions. So the interoperability and the standards, the compliances, and then the seamless adaptation of the certification into the secure communication between the systems. So this is what our experiences while implementing these things and as a part of R&D and into the deployment under the field. So that the experience just I would like to share and today's presentation. Yeah, thank you, sir, for a nice introduction already. So, yeah, this is in a typical small agenda that what we have this our today's my session. So, what the standards in the OT domain and what are different standards in the actively being looked into, and how this the seamless integration of the certificate support in our OT products, and what are different aspects other than secure communication and digital signatures, how we adapt into our products and systems in especially in the OT. So as we all know that OT systems is a part of a critical infrastructure for us, right? So everywhere we have an OT system, there are millions of IoT devices and the traditional OT devices already in the field. The beat and a power and electrical, the electricity generation, transmission and distribution, and energy storage systems, and the nuclear power plants, oil and gas, the railway networks, the aviations. So everywhere you have millions of OT devices already in the on the field, and they are not there today. So they are there from last 40, 50 years. Once this communication capability has adapted into this into the OT world, the basic SCADA system started with all the protocols like Modbus, DNP protocol, I650, a lot of protocols which brought us an interoperability between the different vendor systems. So there are so many vendors are there: Siemens, Honeywell, ABB, Schneider. There's so many the companies which are deploying a critical infrastructure projects across the world. So and this critical infrastructure under the tremendous the pressure or what do you say to protect this infrastructure from the security incidents or the hacking attempts. So how we defend our architecture of our products and systems and with the perceived attacks. There are various incidents already shown that not only the amateur hackers or even the state-sponsored the hackers are getting into the system, trying to get in the system and disturb the and the power systems or the critical infrastructure systems. So this is a typical an Indian power map. You can say the energy transmission distribution. It's basically a transmission. You can see how the transmission lines all over India. So it is we're talking about around 400,000 megawatt capacity in India. So both non-conventional and conventional energy, and we have around 300,000 circuit kilometers of the only I'm talking about transmission, high transmission, the EHV transmission, 725 kV, 400 kV, 220 kV. So we have around 50,000, more than 50,000 electronic devices, we call protection relays or IDs, controllers, gateways, this protecting this protecting this infrastructure. So the many of systems are still electrostatic or with some basic communication from the first level intelligence from the primary system to the first level intelligence, then to the SCADA system, then to the control centers. The whole chain should work seamlessly. So the focus was on to make the system interoperable and work seamlessly, to make it operation, to optimize the performance. But now the focus is shifting towards cybersecurity, how to protect this infrastructure. So there is a burden on the system, because already you know the core embedded systems or OT products already they perform their core operation. These are protection algorithms or the operation related logics are implementing. Now the security aspects and add on to that the communication infrastructure, the Ethernet communication. There are so many protocols to implement and to communicate with transfer the data, and on top of it, now the cybersecurity architecture is coming to the picture. So the electrical, the grid or infrastructure, not only in India, all over the world, it is aging. So almost like the US or Europe, the electrical infrastructure is almost 60, 70 years old. Fortunately, in India, we have developing last 20, 30 years. We already started with an intelligent electronic devices which has the communication capability, but we didn't foresee the security the aspects that time. But when we started adapting to the security implementation, we saw that there's a tremendous pressure on the device architecture, because yeah. So the merging of IT and OT infrastructure, as Dr. Sudarshan nicely put it. So we have a CI triad: the confidentiality, integrity, and availability. So for IT systems, confidentiality is a core of the system. In the priority, high priority, then next comes that integrity and availability. Whereas for the OT systems, and availability becomes a primary objective, because see, when there's a power transmission, when the power trips, or in the power plant, when the power due to overload or due to fault, so you're supposed to operate the system in 10 milliseconds, detect the fault and trip the line, protect the grid from the rest of the faulty system. So the devices which is on the field are deployed, they're supposed to use is continuously monitoring the power signal, the fault cases in that. So that system supposed to perform this core operation, whether the communication architecture is working or not, if the data is going to the control center or not. The communication comes the secondary aspect, but core operation is to monitor the primary system, the power system, and take the action. So that's why the availability is very, very crucial for an OT system. Of course, the confidential integrity is coming as a along with availability, but we perceived that in the beginning, to 15, 20 years, okay, we have an air gap system, so our the networks are isolated from the internet, public-facing networks, but it is not really true. So we have seen the recent incidents in Ukraine attack, or the worldwide many attacks in the US on the water treatment plants, or in the oil and gas network. So we saw that that the people, the hackers, able to get into their IT network. From there, they're getting into the OT network. So the systems are not fully air gap systems. So there are systems which are already directly or indirectly connected to the OT, and so the challenge is how to build a defense in depth architecture. Okay, build a multiple layers of defense, and so that we able to protect the operations, the critical infrastructure projects from the IT hacks, right? Say if you see this simple, there are search engines. This is one of the search engines called Shodan.io. Simply if you put in a Modbus or DNP or I690 protocol, you can see there are thousands of devices, public-facing devices, you can see which are facing to the public internet. Okay, so this search engine crawls into the network, and it try to find out all the OT devices, predominantly OT devices, which is supporting the common protocol like FTP, HTTPS, DNP, Modbus. So just checks those devices. So and say, try to access with some basic default password, username admin, password 1234. So there are still this kind of password, username still there in the OT the products systems. So just using that password, they're able to get into the OT the products. So you can imagine if they're able to control that OT product, and in turn they can control the one power grid. So if they're able to trip the one line or one nuclear power plant, how much havoc can create into the system. The Stuxnet, we have seen that the state-sponsored hackers are able to get into the OT system via their IT network. So there is no one layer or one security solutions enough for us to think of. You should build a multi-layer of defense so that it is making it a little difficult for the hackers getting into the primary system of the OT world. So a recent one of the study report given, if you see a simple search of the protocol called Modbus or BACnet or DNP3, in the US, South Korea, France, there are more than 30,000 devices publicly exposed. You can penetrate, this Modbus protocol, DNP protocols, all these are not secured at all. They are basic communication protocols. The Ethernet-based protocols, they carry data. They don't have any the security layer built on top of the protocol layer. They're simple, still text protocols. Of course, they started as the basic serial protocols, RS-232, RS-485. Slowly, they evolved into the TCP/IP based protocols, but still security is not in place, because for the vendors or the customer, the interoperability is very key. For us, okay, you are giving me a new device with a lot of security. What happens to my existing system? How I can integrate these two? These are the questions they're asking us, customers. So they expect our OT infrastructure to provide a support of 20 to 25 years of life cycle. So which is these days with the fast-moving technology, the processor architecture, so it is compared to other domains like consumer electronics or be it defense. So the technology is getting changed very fast. So when we are expecting, there are substations, there are power stations, they built almost 40 years back, still they're running, okay? So of course, there are electrostatic, electromechanical systems still on the field, but there are systems which are kind of a basic text protocol still working worldwide to monitoring or controlling or protecting the critical infrastructure. So this gives us where we are today and how vulnerable we are across the world. I'm not talking about even Europe or US or India, everywhere. So there are, maybe this is because of the product designer, developer, vendors like the big vendors which are developing the systems, and the customers who are operators who are operating these systems, they are not much familiar with the security concepts. Though the security concept will be there, they keep it at a default state. So they're not updating, they're not configuring properly the security. So we are such a level. So one side we are talking about the high-end PKI infrastructure and secure communication, quantum cryptography. But on the field, if you see, we are just quite behind the people, the primary people who are operating the systems on the field. They don't know how to configure the system, how to maintain the system, how to protect the system. So they left that intelligent device the same as like we have a lot of people, we have smartphones and we have hundreds of features, but hardly we are using 10 features, right? So this security feature is just one of the features in the product, but they left it to the factory default state without enabling or configuring, making it a complex, the right configuration, that those systems become vulnerable. This is the one recent the evil PLC attack. This is how one can attack into the OT systems, making the PLCs and controllers gateways into they themselves become a kind of a rogue systems which can attack into the primary systems. So as I told you, so once the hackers come to know, okay, there are products or systems publicly exposed, then using that those protocols, they're pushing the malwares, ransomwares into the primary systems, the OT devices. From OT devices, they're getting into the engineering stations. From there, and a commission engineering laptop, then once it goes to engineering station, then it is go to entire plant or even entire grid. So this is how they are able to penetrate into the critical infrastructure, and they can create an havoc. Okay, so this study. The Clariote company has done it, and they were saved not just one vendor or one product developer, all across the companies who are developing these OT products, their systems are vulnerable. So that they are able to provide us information. Of course, they, as soon as they found information, they informed to the OT vendors, the product developers. Then they fix the issues. Then only after that only they publish this article. But see, today our OT products highly vulnerable, how highly scrutinized. The researchers, universities, or the hacking companies, everybody trying to buy the system and see what loopholes in the OT products. Look, so and they're reporting, yes, I found some vulnerability in your product. So for the companies, it's becoming a challenge. Like say, for example, Red Hat, what is called red teaming and blue teaming, right? So as a product vendors, we are R&D, we are as a blue team, we are defending the architectures and we defending the, whereas it is easy for hacking people to find the vulnerability in the product, right? It's a constant challenges. So when we had, say for example, an R&D team designed the product and deployed in the market, maybe this 10 years old, suddenly there is new vulnerability reported on the device. So the deploying and patch onto the product which is on the field, it's very, very complex. Unlike in mobile, if you say, okay, they given a patch within 2 minutes, they will enforce, update this patch. So otherwise simply the mobile will say will not operate. So then immediately you do update the patch and reboot your mobile. But rebooting or update the patches and rebooting the device is not so easy. If the OT product is on the field on monitoring the centrifugal pump in the nuclear power plant or the crucial substation, 400 kV substation or generating plant, it is a controlling. Nobody want to take the patch update seriously because they don't want to disturb the system. The plant shutdown is, they have a target to reach a 98% availability. They have to meet the target. They don't want to give us a commissioning, the time for patch updates. So that much of complexity is there, and with this, the patching update has become so frequent. We know that Microsoft every month he releases second Tuesday or something. Every month he releases a patches. He thinks so easy to deploy, but deploying the one patch onto the OT product is quite complex. Yeah, that are challenges the OT product vendors are facing today. Yeah, so. One is, okay, you are making the product, the architecture robust enough to withstand this, the cybersecurity attacks, and building the system around it, right? It could be a physical security and electronic perimeter security, and then implement the proper authentication with Active Directory, whatever. So like you are logging into the laptop and you connect it to the Active Directory server and validate its authentication. We have to take that into a small sensors which is monitoring a transformer, oil temperatures or motor start-stop sensor, the smart sensor. So you want to bring that and activation or authentication into that level, how difficult it is, because you don't have a keyboard or you don't have a mouse or to operate the device. It doesn't have any user interfaces to write user passwords, right? So this is challenges when we have this the kind of medium and low end, the smart IoT devices or it is an OT devices on the field, where you need to log in and do some configuration and change the parameters, read and write the parameters, right? So we recommend usually to the vendors, okay, you build a system. So you make it kind of a multi-layer security layer. So, and you protect the external communication with your proper firewall or IDS systems. But here at individual product level also, you should see, okay, if somebody able to penetrate your firewalls or IDS systems, getting into OT products, how you defend your architecture. So how you detect this is a hacking attempt. So what are the procedures? How you find it is in a DNS attack or the fuzzing attack. So and detect and see, ensure that any DNS attacks are not affecting the core operation of your OT device, right? So that is a challenge we always face as R&D team. Yeah, the OT device, security device architecture, if you see OT device, like I said, it is a dedicated the embedded computing system or product, you can say, which is performing the core operation. There are thousands of protection algorithms which is actively monitoring a transformer protection, or be it a transmission protection, or be it a nuclear plant protections. So they have an algorithm to run, which is very intensive. Your analog current and voltage signals are coming at 50 hertz per second. You're sampling at 1 kilohertz, 4 kilohertz, and then you measure the analog sample, convert it digital, and measure identify the fault, and then take an action and trip that particular the faulty product or transmission line from the rest of the grid, which has to happen in 20 milliseconds. So for example, 50 hertz a power cycle, which is a 20 millisecond per cycle. So you have to trip the breaker or protect the power system in the 10 milliseconds when the zero crossing is there. So that is a core operation of any device. Now the communication is ADAC. So it has to communicate with the control center, and it has communication with the SCADA systems. When the cyber attack happens onto the OT device, it needs the system resources. It takes over the CPU processing power. It takes the runtime memory. So then the trade-off between, is it the core operation is important, or it is a communication security is important. So that's where how you prioritize task, how you ensure that your the attack onto the OT device is still not affecting the core operations. How you segregate, how you build your architecture, the embedded architecture to handle this kind of attack when still the device performs the core operation. So that's how we constantly look into it, and we scrutinize our products into that, create that attack scenarios and see how the OT product is able to withstand. So different the OT standards predominantly providing us guidelines are the compliance requirements. This is an IEC standards, or it's NIST standards, ISO standards, and the NERC standards. And every country is coming up. Every country that there is a regulatory committees. They are bringing up the guidelines, the trusted vendor concept, supply chain security. Yeah. So the SCADA interoperability, then the cyber security. So authentication, the encryption, the secure communication. There's so many requirements. So for us, the challenge is to meet this the standards, the compliance requirement, get the product certified, and then at the same time the seamless integration to the system to have the effective communication, the transfer data for the effective the monitoring and control of the grids or the critical. So this is the challenge. So predominantly we see this 62443 is quite popular and across the world. It started as a simple ICS, industrial control system standard, but today this standard is being adopted almost all critical infrastructure domains, be it in energy storage systems or be it in oil and gas, water treatment plants, the aviation, railways. Everybody wants they want this compliance with 62443 standard. This is a vast standard. It covers all the aspects of system security, product security, everything, and standardization requirement, the testing, certification. Yeah. This is the 62443 kind of the number of parts we are talking about. There are so many the standard parts. So predominantly we see the 3-X, which is called of system security. When you build a system, the critical infrastructure system, how you protect the system. And there is a different layers of, there is a process IO layer, field device layer, and this control network layer, then the enterprise network layer. So how you build the system, how you secure the system as a network architecture. Then the 4-X, this part called individual product level security requirements. How you implement authentication, how you implement your secure communication, how you implement your the trusted vendor, the code signature, patching practices, all those requirements which is coming under 4-2, the 4-1 and 4-2. So this is the compliance, the standard compliance which always we try to adapt. And sometimes what happens, these standards will, okay, this is the requirement. Okay, then how you'll implement it, that may not be that clear, but that we need to see how we practically implement these standards expectations. Yeah, so this is a typical, for example, you can take a substation or it's a kind of the thermal plant or hydro plant. So where we have this different network layer, so FD and the bottom layer, field IO layer, and this is the second layer is the process control layer. Then third one is the demilitarized zone, and fourth is the enterprise network. So where the IT system come into picture. So we talk about a firewall in between different layers, and we have IDS systems. And yeah, in between we have a wireless connectivity. You connect to the wireless modems, or you connect to the remote stations. So how you safely create a kind of a secure conduits into the different layers, so that you have you are able to validate the information before getting into the primary system. Yeah, so here we know as I mentioned, so there are the product suppliers standard requirement and the system integrators and this asset owners. So these systems, the different the parts, the product supplier layer, where you have embedded devices, you have a network components, where your switches, host devices, your applications running on this product level, and the system level where the third-party integrators who takes the products and builds into a system for the customer. And asset owner, the end operator or customer, an oil and gas plant, an operator, so who owns asset and regularly maintains assets. So what is his requirement from the cybersecurity perspective? So just how this PKI system being referred in these standards. So the challenge, what they're talking about, how we secure our communications between the devices to the control centers or to the SCADA systems. So the 62443 standard, when you devise an OT product and embedded controllers, gateways, RTUs, protection relays, so we look into standards. They talk about, yes, you should be able to support the PKI infrastructure. So your certificate must be signed by PKI. Okay, correct? Okay, fine. So what are challenges there? Our devices are directly connected to PKI every time? It's not possible. So all devices are not directly facing the public access to the CA system. So what are the fallback options we have? So that is something which we need to think of. Every customer or every small operator in the kind of paper and pulp industry, or in a kind of the small and steel factory. So they may not have a connection to the 24/7 PKI infrastructure. So how you support that kind of a small industries, and your products should be still able to provide some basic protection. Yeah. So then comes up the size. So what should be the PKI size? What is your symmetrical key size? What should be your RSA key size? It is a 1024, 2048, or 4096. Is it enough? What standard says how the IT world is moving? So whether your system can take, because the system has to communicate with the multiple masters or the clients. So every one particular device is communicating the local maintenance system, the local engineering station, local operating stations, then remote control center. It is establishing a parallel sessions, and every session has a TLS handshake, and every session has a security certificate check. How much it takes a system, so what is the impact on the performance of the device? So so that is a challenge. So that is we kind of a design engineers will face. Okay, what the system is capable of, and how much that can impact on the operational performance of the device. This is 16235 standard. This is mainly, as I mentioned, is a power system management standards. So this is the standard mainly followed in the electricity, the power and energy automation project. So this has a more detailed implementation methods. They have proposals like how we implement. So especially the part 9, it talks about cybersecurity key management, how you manage your keys, how you manage your certification, how you manage your signatures. So this is what we would like to, we usually refer, okay, what is the compliance requirement? So, so this is one of the chapter it talks about certificate handling. So how you, there are three scenarios. One is a product vendor who's manufacturing the product, and it goes to the system owner and the device itself. So the system owner is the end, the customer, and who's installing the system in oil and gas plant or a substation. So how this certificate is created, how is certificate is, installed in the device, and the lifetime of the certificate, and how the device should take the certificate and use it for its communication, right? So these are the production, then registration, commissioning, enrollment, and renewal. So all these stages where the vendor comes into picture, where the system integrator comes into picture, and where the customer is coming to picture. So what his responsibilities? So most of the times what happens, OT product, off-the-shelf product. So we have a production relay, we have a gateway, we have a controller. So most of the times the companies are not the one who goes and integrates into the system. And oil and gas commissioning is taken over by done by some company who is a basically system integrator. He takes the product from multiple vendors, so he integrates and makes a system with his own engineering stations and commissioning systems. So multi-vendor device. So when we develop a product and deploy the product, we give the product to the system integrator. System integrator purchase a product from us. So what should be the factory default configuration? Okay. So because we don't know, because we are not the owner of the certificate, so we don't know which certificate the customer wants to finally put into the product. So it is up to them. If he has, a customer has his own PKI system, for example, BESCOM is a Bangalore Electric Supply Company. If he is commissioning 133 kV substation or 132 kV substation, so he may have his own PKI system. He wants his certificate to be there in the product, right? So we can, when we produce a product in the factory, so okay, by default, the product will go in the self-sign certificate. Okay. So if there is no certificate inside the device, okay, we update the firmware and we start the first time. Okay, the firmware should check, okay, there is no certificate. What happens if the customer doesn't have any certificate PKI infrastructure, or he don't have an connectivity to this PKI system? At least we should have one self-sign certificate. Okay, as soon as the device boots up, it says the first time it checks. Okay, there is no certificate inside. Okay, let us create one self-sign certificate. As I told, the life cycle of the product is being expected minimum 15 to 20 years of life cycle, be it in aviation or be it in railways or any product we sell. The customer expect, okay, how much support you can get it. Next 20 years, can I use this system? So that is the expectation set by the expected by the customer. So whether the certificate, we should keep the 20 years of validity, and whatever the key we use, 1024 bits or 2048, is it enough after 5 years? We don't know, right? So that's the kind of a constraint we face during design stage. But usually we put that self-sign certificate as a factory default. Then the customer is able to upload his own certificate. Then it should be able to take that new certificate. So that's how we plan that in a part as a part of design. As second is the manual external certificate. So okay, the customer has a certificate. You want to deploy that onto each and every OT device in the field. Okay. So we have an engineering tool, and you generate a certificate and trust a certificate from the CA. Take it to the using the engineering tool. Just you deploy into the device, and in the device we ensure that we need to keep it in a safe and secure location, which is not so easily accessible by any other SCADA protocols. So that option we should have it. Then the third is automatic exchange of a certificate, which is it should have a connectivity to the PKI, which is there is a possibility for that OT device has a direct connection to PKI. Okay, then the device can generate its own keys and send a public key as a CSR signing request and send it to the CA, and CA signs it and sends it back, and we store it in the device. So we should have all these three options to be given the customer based on his infrastructure. Whether if a small operator is a big operator, how much infrastructure he has, he should be able to use this system or product into his system. So if the customer doesn't have his own the PKI system, okay, he can live with the self-sign certificate, yes, but engineering is a complex. So you know who's your client systems, your HMIs or your control center maintenance engineers. Okay, you take the science leave certificate and you do the pre-install so that, okay, your HMI systems can only recognize only that pre-installed certificate. So there is a constraint, but still it should work as a basic defense. So the manual certificate update, where you have a different tools, you have your local CA or your public CA. So you take the CA and you generate a certificate and you bundle it PKCS 12 and transfer it securely to your engineering tool. From there engineering tool you deploy onto your OT device. So this option also will help how securely we generate certificate and we store into the device. And of course, as we all know, this is automatic certificate exchange, which is quite predominant, popular, means regularly being used. So how the OT device should implement these features with minimal resources. The four steps, like, okay, you request certificate signing, whether you want to generate your own key pair internally device, whatever resource you have, whether you have OpenSSL stack, you are in random generation, key generation mechanism inside a device, or you have your own TPM inside the device. You generate the key pair and send the public key for the, send a CSR to a PKI, then request for an auto enrollment, and then you get the enrollment and you receive back the certificate back to the device automatically. Then you keep monitoring the expiry of the certificate. So these looks very small, but when you start implementing embedded systems where you have to write your code on the C or whatever the embedded software code, the renewal, you put a timer and put a low priority task to check that expiry of the certificate. Then before 30 days, then you apply for renewal. Then check the revocation status of the certificate. So there's also one low priority task, check the revocation status and connect to the CRLs or OCSP, how you have an access to the CRLs, CRL deployed machines, points, distribution points, or your OCSP responder. You allow to configure that, then you monitor the certificate revocation before establishing connection. So these are the basic steps for any PKI infrastructure when we implement that in the OT product. So keep it straightforward and with a minimal implementation and keep it seamless. Based on how the customer would like to pre-install, what the infrastructure he has. So you should keep it in mind, provide all the option to the end customer. It's not a one solution. So this is the solution which could be allow any customer or the product integrator, vendor, an operator, starting from a small the oil and gas station, or it's from the aviation and a ship inside the ship, an aviation system. So he should be able to integrate this into his system. Yeah. So. Yeah, so as we know that as the OT device, you should have a kind of a small PKI client component inside an embedded systems, which request for the CSR. So this also kind of as the 623 standard 9 so talks about how we can implement your the CSR renewals. So what different options you should give, whether CRLs or OCSP, what options the customer has, whether he can support all the options. And deploying automatic certificate update on field. So how the commissioning engineer or CA administrator, the steps the CA administrator take, then he configures NDS service and then the device goes to the field. You deploy it onto the remote oil plant, the oil extraction platform in the sea. So you deploy that, your protection systems there. Then your commission engineering, we provide the CA certificate, the thumbprint into the device. Then you have request go to the RA server. If you are able to reach the RA server, then you send a CSR request and get the certificate and keep monitoring the renewal, the expiry date of the certificate. So there are chances that your device is not always online. There are chances that your product is not always able to connect to the PKI because there could be connectivity issues. How to monitor whether he can survive with the existing certificate or expired certificate, what decisions the product has to take. Okay, whether we can live with the expired certificate or we should prohibit an operation on the device. So these are the challenges in the OT product vendor and customer face. Yeah, the certificate renewal options. How you create the certificate, and the renewal, wait for the timing out and implement that. Then with respect to that CRLs and OCSP implementations, so there are trades how much CRLs list you can store in your own memory location, because there are memory constrained devices. The dedicated device may not have your huge memory like a big HMI server or PC based system. So whether you can connect to CRLs or you can give both options, go for an CRLs. The CRL, the challenge, the CRL, okay, the CRL is checked before your TLS handshake, or if you OCSP, then you first establish session, then check the OCSP status. So how it can support both. You give an option to customer. Okay, so if you have a CRL CDP in your systems, yes, then you can choose this option. Or if you have an OCSP option, okay, you can choose this. So like that, and the product vendor or developer, so they should provide all the option to the customer. Should consider these things in its design, product design. The second aspect is the way the PKI is coming into the picture is the digital signature, because the trusted vendors concept. So the image patching, what comes from our product vendor, whether it is coming from the authorized source or not. So that is the device has to check that the validity of the patch. So that's where then you sign you store the public key of your CA into the product, and you deploy that product onto the field. So then when the patch is released by the trusted vendor, then the patch is verified from the CA. So okay, verify the signature of the patch. So this is where we also use the support, whether say like we have the option of like, okay, we have our own local CA, or we should go for a PKI infrastructure where our key signatures are our private keys are held by the PKI team, like DigiCert, semantics, or various options what we have across the world. So then you get the signatures signing request during as a part of our build, then release a patch to the customer. Then the customer, when he is deploying onto the field, so that system has an access to the PA to verify the signature. Okay. So yeah, so we have seen that this signature verification, code signing, is a part of our secure boot implementation, is a hardware root of trust in the OT device, whether we'll have a safe secure memory location or it's a TPM inside the OT device, where you verify the signature. So predominantly we are seeing the two major implementation. One is UEFI secure boot, or it is a U-boot based secure boot. UEFI secure boot mainly predominantly used in the PC based architecture, where you have a BIOS, a UEFI BIOS, and where it supports your signature verification, and it allows you to store your hash, signed hash, or the public key certificate itself into a safe memory location, NVRAM. So it's not only the your signature, also it needs as a UFI standard says it needs an the public key, platform key, and key exchange key. So which key used controls access to your database, the DB and DBX, where it's a DB has this valid signature and DBX has this block list the signatures or certificates. So during your signature verification, so you go, the certificate is on during operation, your patches are verified by the code signing, the CA, and signature verification before looting, starting from the pre-bootloader and bootloader, then kernel, the OS kernel, then your root file system. So everything you need to sign to ensure that with the public key inside your secure memory location, ensure that only authorized vendor or authorized softwares are booted. Otherwise, once if you leave the room there, already the standard clearly says that okay, you should have your own, the product should have its own hardware root of trust, and the possibility of use of TPMs or secure memory location should be allocated within the OT device. So that's where you store your the keys, important keys, and the respective database within your architecture. So the high-end devices like controllers, gateways, where we have industrial computer grade systems, which can have a good amount of memory and processing power, they usually adopt this UFI. Or if it's a kind of a primary embedded systems, which is a very minimal memory and the communication capabilities, we go with the U-boot based, the ARM architecture based embedded computers, where the bootloader provides an access to then a TPM, and it allows you to signature verification, allows you to implement your secure boot. So based on the what device we have, where it goes on sit, whether the station computers or the station controllers or the field devices. So based on that, so based on the different architecture, we implement this the code signing with the with the support from the PKI infrastructure. Thank you. Then yeah. So there are standards or guidelines which accepted worldwide. So we are these standards are keeping in touch with this all the IETF other standards for the latest happening in the PKI world or in the cryptography world. So they update that guidelines into these standards, and as a product developer or companies, we look up to these standards, and these customers also say that okay, your product must be compliant to this, certified by these standards. So we design our product, implement our the secure development lifecycle practices or the product requirement in compliance with these standards, and yeah. So these standards have the already the provision or the telling about the product vendors take into the consideration of PKI infrastructure in your design, how to integrate PKI infrastructure into OT or product at the primary system level to the high-end system level. You provide a seamless integration support or into your product architecture. So these things we keep in mind during our product and development. Of course, once product is deployed, it's not that it's safe. We know that after the device is there in the field from last 5 years, then suddenly there's a vulnerability reported on the particular Linux OS or embedded Linux OS, then again get panic starts. Okay, then you create a patch and deploy it the customer, and the customer has to have a time to deploy that patch into the field, so under the product. It's very complex life cycle, but still, so that is making the system is vulnerable, and we are in a catching up mode because we have a lot of other challenges like operational challenges into the system. The security becoming kind of an additional task onto the existing product architecture, but yeah, the standards are so changing so fast. Like first they came to TPM 1.2, within 2 years, no, TPM 1.2 is no longer valid. No, you go to TPM 2.0. So it's not so easy. So say the products are deployed and say that within 2 years the TPM is no longer is standard, then you cannot say the customer, okay, the TPM 1.2 is no longer used, so you should go for a TPM 2.0 upgrade. Then customer will ask us, come on, I have purchased the product just 3 years back. You cannot say that it's now no longer usable. So that's the challenges we face, not only in India, in everywhere, across the globe. The product companies, the customer, always there is a uh, the kind of the heated discussions. But in these where I think these standards are helping us. Okay, see, this is standard. This is the neutral standard. It is developed by or maintained by a neutral organization, and organization like TUE organizations, their certificate agencies, they work on along with this standard companies. So we take their the compliance audit, and they will certify our products. At least that gives a neutral ground for us. Okay, see, the standard changed. That's why we are changing. We have to adapt it. So that is a balance we try to maintain. Thank you. Thank you for time. Yes, yes. Because this is, as I said, these standards are global standards. Everywhere, even the Indian, so for example, CA or IEMA in India, so the regulatory bodies, so they insist that our product must be certified by these standards. So we have
But
to,
you have been mentioning in one of your slides the CA certificate issued by DigiCert.
yeah.
But that is not in my
No,
CAs,
not
right?
CA. Where is that?
In one of the CA slide, just go back.
We just the CA. We don't say that which PKI or it is this thing. So the CA could be anything.
But
It could be,
if you're going to, the CAs like DigiCert interest varies on. So these are the CA which is not even related to my PKI ecosystems.
yes, yes.
Then how your product is with this international standards going to apply us?
Say, for example, as a product vendor, we don't say that, okay, we'll go for this CA or that CA. Okay. So
When
we
you want to
leave it
come
the
into my
operator.
when you want to come into my PKI infrastructure of my Indian ecosystems,
Yeah.
you have to go with my CAs
Correct.
for entrusted route.
Correct.
Our CC India route.
Correct.
If that is not it, then you are going to rely on the outside third party.
Correct.
Then it means that you are going to follow the outside standard in my Indian market.
Yeah. So here the standards
No,
are
when you come back to Indian market, you have to come back to our PKI systems.
correct. So our products are not dependent on any particular CA. So our product, the product what you develop in the OT products, they're supposed to support any PKIs. For example, the products developed is, so for example, Reliance, in the oil and gas, you want to install a product. Our certificate should be signed by CA. So definitely product should provide that option, the import those certificate or connect to the local, CA.
That's
and
why
get
Reliance
signature.
is become a CA now
Yes.
with us.
Yes.
This is the reason behind that, maybe.
Yes, the product should give that seamless integration. So that's why we don't say which CA it is. Any CA, okay, you tell you configure that CA. So okay, this is a CA where the certificate must be signed. So the product should support that. It's not only anybody. This is how the standard says. The standard will never say you go for this PKI, this PKI. Should be PKI enabled. So that's all. So the standard doesn't talk about any vendors. So they are pretty neutral, which is followed by across the world and across the domains. So
If I understand right, they are using self-signed certificates for internal
self-signed
activity.
certificate is just a factory default. So when the product goes to the from manufacturing company, because we are not owning the product ultimately owned by the customer. So we don't put our own certificate in that. So we give the product the self-signed certificate. Then we provide option to the customer to configure his own CA and put his own certificate during the commissioning stage. During commissioning.
So finally, commissioning stage, they are coming
Yeah,
back to
the
CS.
deployment in the on-field deployment, the customer has his own CA. He should be able to put in his certificate onto the product, and he should connect with his system.
But try to come back to my infrastructure.
Yeah,
So that will value the more to the Indian
definitely.
ecosystems.
This product should. That's the idea is any OT product should provide the support the local PKI infrastructure. So that is a core. Even the standard also says doesn't say anything. So you should be able to provide a seamless integration to the local regulatory bodies or local CAs or local PKI systems. So that is anyways very clear.
Okay, thank you.
I have one question. Renewal and revocation have always problems.
Correct.
If people are scanning.
Yes.
So how do you overcome that?
Which one, sir?
Scanning,
Yeah.
when people are renewing or when the revocation or when it has delegated and the certificate has revoked because revocation is not monotonic, these are the serious problems in which the failure happens.
Correct.
How do you handle that?
Yes, sir. So that is a challenge actually, as you rightly said. the OT, the product vendors or system vendors cannot control this, because what happens after 1 year, we don't know the certificate which we deployed in the systems no longer valid or is already revoked. So it is again the customers the decision that we have an option where you can specify which CRL to be checked, which CDP should be connected to check your CRL distribution points to be connected, to request for the verification, or which OCSP responder you need to connect. So that's where the configuration points are there. But ultimately, it's the customer, he has to provide the right configuration path. Okay, as a OT product, you should reach out to this CRL or list or CDP or this OCSP to validate certificate before establishing the communication. So ultimately, the system owner has to take care of that.
Thank you, sir. Thanks to all of you. Thanks for a wonderful
Thank you.
presentation.